Practical subnetting. Based on the information in the graphic shown, design a network addressing scheme that will supply the minimum number of hosts per subnet and allow enough extra subnets and hosts for 100% growth in all areas. Circle each subnet on the graphic and answer the question below. Alright, what do we got here? I'm just making sure. Alright, let's get a eraser to erase that. Alright, let's get back to the brush. Alright. So, address class. We have an IP address starting from 210. So it's a class C. Class C has a range from 192 to 223. So we know it's a class C. And we know that the default subnet mask of the class C IP address would be 255.255.255.0. Now we need to find the custom subnet mask. But that's a really long process. We're going to get back to it. Let's fill out these criteria. Alright, minimum number of subnets needed. I'm going to disable these guys for a second. That, and let's get an eraser and erase that. So the minimum number of subnets needed. As we can see here, the topology, we have a router that has two interfaces, F0/0 and F0/1 from that interface and that interface. So we have a total of two networks. This is one and this is the other. So the minimum number of subnets needed would be 2. Okay, so extra subnets required for 100% growth. And let's get back to the question, and we need to find the 100% growth in all areas. So extra subnet required for 100% growth. 100% more of 2 would be 4. So we got that. Wait a second. No, that would not be it. To make it the 100% of that number would be 2, and the total number of subnets required would be 4. Alright. Number of host addresses in the largest subnet group. Okay, so what is that? We have 10 hosts in there, 15 hosts in there. So that would make it 25, and we have 18 and 12, so that would make it 30. So the number of host addresses in the largest subnet group, that would be 30. Number of addresses needed for 100% growth in the largest subnet, so that would be 30. And we add them up to find the total number of addresses needed for the largest subnet. So 60. Alright, so we got got to this point, so this is what we're gonna work on now. Let's get an eraser, erase everything. Alright. So we're solving for custom subnet masks. Alright, how do we do this? We're gonna have to refer to our HSB. The HSB method, that would be host, subnet, and binary. So we're gonna put on the values. It's 256 and 128, 64, 32, 16, and this is something we all have to memorize for 842 and the inverse value for the subnet, so that would be 4. We basically inverse that. 8, am I going it right? Yeah, 16. What am I doing? Yeah, that's right. 32, 64, 128, and 256. And for the binary, you gotta start from 1. So that would be 1, 2, 4, 8, 16, 32, 64, 128. Alright, so we are looking for total number of addresses. Right, so we're looking for the total number of addresses needed for the largest subnet. So we gotta look for something that can hold 60 hosts. So 32, it won't, that's not gonna hold 64, 60, so 64, alright, we can fit in about 60 hosts in there. So we're gonna draw a line right there, and see we have a matching criteria. Total number of subnets needed 4, so we have a match, and on those 4 subnets we can fit 60 hosts, so we have a positive match. So let's go ahead and mark that point. So what did we do? We borrowed 2 bits. Alright. Now if we were to look this on a binary, if we were to see this as a binary, it would be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2. Right? And the rest of them would be zeros. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. So this is what we have. So all of these values added would make 255. 255. 255. And this 2 would make it 128 plus 64. Remember all these ones, 1, 2, 3, 4, 5, 6, 7, 8. This is 128, this is 64, 32, 16, 8, 4, 2, and 1. Right? So we added them up. So 128 added 64, that would be 192. Alright, so we found our custom subnet mask. It would be 255.255.255.192. I'm going to go ahead and clear these up. You're going to have to find IP address range. Alright, IP address range. Just checking my pen. Alright. So the IP address range, these are the values that are gonna hold the, see, basically we're trying to assign IP addresses for these guys right here, the computers in science room, and the English room, and the tech ed lab, and the art classroom. So we don't want to waste any IP addresses. The whole purpose of doing this was to make sure that we don't waste any IP addresses. So if there is any problem while we troubleshoot, it will be easier for us to locate and to organize things. Alright, so IP address for F0/0PORT for this guy right here. So what would it be? We know that we have an IP address assigned to 10.15.10.0. So that's where we're going to start from, and we have to look back to the to that chart we had before. Alright, we're gonna have to go back to where were we? Alright, come on. It's gonna take a while. Forgot to mention one thing. Okay, so it's not going back. Alright, so we're gonna have to get that those values one more time. I apologize, I should have mentioned this before. Let's get back to Edge ASP 256. This is going to be a good review. 128, 64, 32, 16, 8, 4, 2, 2, 4, 8, 16, 32, 64, 128, 256. Yeah, that was a good review. 1, 2, and 8, 16, 32, 60. Where did we go wrong? All right, 4. Brush 4. 8, 16, 32, 64, 128, and we remember that this was our scenario right here. We had 4 subnets and 64 possible usable IP addresses. Now, well, not 64. The network and the broadcast, we can't use them, so 62 possible IP addresses. Alright, so now, I forgot to mention this. See this 64 right here? The bits we borrowed, remember? This 64 right here. I like to, this is a bit tricky, you're just gonna have to remember it. We draw a line, the number on the left to it, on the binary value. That is our magic number. Alright. we're just gonna have to remember it like we remember the host subnet and binary. We have 4 subnets that can have 64 hosts. Alright, and on the left we have 64. That is our magic number. And what this 64 does is it's going to help us find out our IP address range. Alright, so since we have a given IP address class C 10.15.10.0, that would be our starting point. So we increment this by 64 to 10.15.10.64. Oops, but wait a second, we can't use the broadcast. We have to subtract 1 from the broadcast, so we can only use, there's only 63 usable IP addresses. So for port F 0/0, we can have that would be our IP range. Considering the fact that we can have we will be working for the 100% extra growth, that would be our range. We could use anything from 0 to 63 as an IP address for these guys right here. And basically what we do is we cannot use the network address, so we're gonna start from 64 to, we increment that value by 64, because that was the magic number. So 64 plus 64 would be, is that right? That's right. I'm sorry about my handwriting, it's getting much worse, but then again, so 127, so 210.15.10. Sorry, 128, we cannot use the broadcast value, so it's going to be 127. So that is how we do practical subnetting 5.